Hey guys, again, sorry for not being able to be there today, but wanted to make sure I got through the notes with you so that you could watch this and then continue to work on things in class. Remember, if things don't make sense, that is totally fine. I get it. It's not as easy to learn, from a video. So just make sure you come to class with questions on Thursday so we can talk about things and practice things. So we left off in two of my classes. Finishing the example, the third root of 243. I know in one class we got one more done, but I did want to walk through these other examples here so you could see them. So we can see we're looking for the fourth root of 81. So we need a factor of 81 that can be written with a fourth power. So if I do my factor tree on 81, you can see I can write that as 3 to the fourth. And since there are no other factors in my prime factorization down here, the 4's cancel, and the radicals completely simplify out, as opposed to our example with the third root of 243, where we still had a radical left in our simplified expression. So here, breaking down 121 is 11 and 11, so that is 11 squared. And so when I take the square root of 11 squared, again, very nicely, the radical completely simplifies out, and I'm left with just 11. One more that's going to work out very nicely is the square root of 64. I can break that down into 8 times 8. Now again, I could keep going, but I'm going to stop here, even though they're not prime factors, because what I'm looking for, don't forget, is something that I can write to the second power. So as soon as I break this up into 8 times 8, I can write that as 8 squared. Right, and so I can have the second root of 8 squared, the roots cancel, and I'm left with 8. Now, if you had worked 64 all the way down to its prime factorization, 8 and 8 would be 4 and 2, 4 would be 2 and 2, 4 and 2, 2 and 2. What I essentially have is 6 factors of 2, right? But again, I don't want something to the 6th power, I only want something to the second power. So I would then pair these up separately here as 2 squared, 2 squared, and 2 squared. So each of these would cancel, and 2 times 2 times 2 would still equal 8. All right, so we have the fifth root of 776. Now 776 is a pretty big number, but we can always it's even, so we can always divide that by 2. So if we divide 7,776 by 2, we are going to get 3,880, which again I can divide by 2. Will give me 1944. Once again, I can divide it by 2. 972. I will tell you, we're not going to give you one this long on a test or a quiz. 486 divided by 2. We get 243. Now we already factored 243 up top here as 5 factors of 3. So I know what I'm going to have here are 5 factors of 2 and then 5 factors of 3. So I'm going to have the fifth root of 2 to the 5th times 3 to the 5th. I can split those radicals using my property and get the fifth root of 2 to the 5th times the fifth root of 3 to the 5th. 5's cancel, leaving me with 2 times 3. And my final simplified answer would be 6. All right, third root of 32. Again, we break down 32 to 8 and 4. 8, 4 and 2. 4, 2 and 2. So again, I have 5 factors of 2 here, but again, I only want a power of 3. So I'm going to write them as 2 to the 3rd times 2 squared. Split my radical so that I can use the powers, the power, to cancel the root, which simplifies to 2. The 2 simplifies out of the radical. However, my third root of 2 squared cannot be simplified, so I am left with the third root of 2 times 2 squared, which 2 times 2, which is 4. All right, a couple more here. 1250 Let's get this started a little bit bigger with 10. We can see it ends in a 0, so it's divisible by 10. That can break down to 5 and 2. I can go 25 and 5, and this can go 5 and 5. So you can see what I have here is 5 to the 4th times 2. I'm just going to bring this down here a little bit, right? So I can rewrite that as the 4th root of 5 to the 4th times 2, split my radical, 4th root of 5 to the 4th times the 4th root of 2. The 4th roots cancel, leaving me with 5 times 4, the 4th times the 4th root of 2. All right, last one here, 4th root of 160, 16 and 10. Break this down to 8 and 2, 4 and 2, 2 and 2, and this can be 5 and 2. So you can see I have 4 factors of 2 right here. So that is what I'm going to want to use to rewrite my expression there, but I still have a 5 and a 2 left over. So when I split this up here, the 4th root of 2 to the 4th is what I care about the most. Now the other stuff I know is not going to simplify, so I'm actually not even going to split that up. I'm just going to leave that underneath one radical because it's not going to simplify. So we'll end up with 2 times this 4th root, sorry, let me get the 4th root in there, 4th root of 10. All right, I know I went through those kind of quick, but you can obviously go back and watch my steps there. These problems here, I will put work on real-time board, and each class is real-time board, so you can check the work, but due to the video already getting a little bit long, I don't want to make you sit through me working out more problems. These are a little more advanced. After you simplify the radicals, you're going to have to then further simplify the expression. But again, I'll show the work on these on real-time board. So just go ahead once you're done with the video and check real-time board if you want to know what those simplify to. What I wanted to finish the video with was coming back to our rational exponents. Now, the great part about simplifying exponents with expressions with rational exponents is we already know how to. We will just use our 5 exponent properties. So those 5 properties are coming back. Again, I don't care if you know the names. I don't even care if you know the numbers that we gave them. I care if you know the if, comma, and the then of each property here. So if we look at our first expression, I am multiplying the same base. So if I multiply the same base, I add my exponents. So what this is going to become is x to the 1/3 plus 5/6. Now when we add fractions, yes, I know, dreaded adding fractions, we have to find a common denominator. So the common denominator between 3 and 6 is going to be 6. So this will become x to the 2/6 plus 5/6, which will, when we add them, will just be x to the 7/6 power. All right, here we have an exponent outside the parentheses with exponents with a single term inside. So this is property 2. I can multiply this exponent by each of these here. So I will get x to the 3/2 power. I will get y to the 1/2 power. And now I have to multiply fractions. We multiply fractions by multiplying straight across, numerator, numerator, denominator, denominator. So I'll end up with z to the 3/8 power. Since there are no more like bases, no negative exponents, no exponents of 0, and I'm not dividing any bases, that would be my simplified expression. All right, now this one looks really big and nasty, but it's actually not too bad. Let's use our negative exponent property. I can say I have negative exponents, so I'm going to move the position here. So that will become 8a to the 4th, b to the 3/5. I wrote over it there, almost couldn't read it. B squared, and then on the bottom, I will have 12a to the 2/3, c to the 1/7. All right, on top, I'm multiplying the same base, and you can see with the a's, I'm dividing the same base. So these two exponents I'm going to add. These two exponents, the 4 and the 2/3, I'm going to subtract. When I subtract, I'll just do the math over here, 4 minus 2/3, right? We have to find our common denominator, which will be 3. So that is 12 over 3 minus 2 over 3, which simplifies to 10/3. So I'm going to have a to the 10/3, and since 4 is bigger, that a to the 10/3 is going to go in the numerator. Here, 3/5 plus 2, I'll do that a little bit higher here. 3/5 plus 2, common denominator is going to be 5, so 3/5 plus 10/5 here. All right, and that will give me 13 over 5. And since both b's are in the numerator, that is also in the numerator. And the denominator still has the c to the 1/7. We're not done yet, though, because we still have a fraction here to simplify. 8 over 12, I can cancel a 4 out of both of these, and that will simplify to 2, a to the 10/3 times b to the 13/5 all over c, that's not a c, that's a 2, all over 3 c to the 1/7 power. All right, you will definitely have problems like these in your homework. Again, if you get stuck, please, please, please come to class with questions on Thursday, and we will go over them and work through everything we need to work through so that you can understand this stuff. Thank you very much, and I hope you have a great day.